Hi, this is Dr. Eddie Morgan over at Clovis East High School, ready to help you with your homework tonight. We're looking in Math 1, Worksheet 2.4b, so let's get started. In all of our problems today, we have the same essential format. We're going to look at the equation that we're given, and then we're going to plug in x values, and then we're going to establish what the y value is, and then we're going to graph it. One of the key things we're always looking at here is what values do we want to pick for x. Well, I notice this is a linear equation. I only need 2 points to draw the line, but I'm going to pick several points, and I usually try to keep it easy. So I'm going to pick -1, 0, 1, and 2. So the first one here, let's plug it in. So we have 3 times -1 minus 2. So 3 times -1 is -3 minus 2. So y is going to be -5. For our next one, 3 times 0 minus 2. 3 times 0 is 0. So this will be -2. And then we have 3 times 1 minus 2. So 3 minus 1 is 1. And then we have 3 times 2 minus 2. 3 times 2 is 6, minus 2 is 4. By the way, notice one thing that should be true. We see that this is 3, so we're not surprised that it's just going up by 3 each time. Just pointing that out to remember that's because we're going up by 1. So let's graph them. Our first point here is -1 minus 5. So I go -1 and then down 5, 2, 3. There's the first point. Our second point here is 0 minus 2. So we don't have to go any place there, 0 and then down 2. Third one is 1, 1. So from the origin, over 1, up 1. And then our last one is 2, 4. So from the origin, always start from the origin, x2 and then up 4. And that's our points, and now we can simply draw a line through that. And so if I draw my line here, through here, and that's my answer, straight line. Again, the next question is also linear. Notice that I have just a single x, so I know it's a line. So I'm going to use the same one, simple. -1, 0, 1, and 2. 1 and 2, 1 and 0, -1, I know are going to be easy to calculate. And since it's just a straight line, I just need to get a couple of points here. So let's put it in. First, we have 8 minus -1. Now, subtracting a negative ends up being 8 minus a -1 becomes 8 plus 1, or 9. Next one, 8 minus 0 is simply going to be 8. 8 minus 1 is going to be 7, and 8 minus 2 is going to be 6. Notice here that my slope here is -1, so I'm not surprised that this goes down -1, -1, -1. Now my points up here for x and y are going to be -1 and 9, 0 and 8, 1 and 7, and 2 and 6. So we get started here, -1 up to 9. 1, 2, 3, 5, 6, 7, 8, all the way to the top. 0, 8, 1, 7, and 2, 6. Okay. So if I draw my line, it's going to come through like this. You can make a better line than me because you could do a ruler and make sure that that's absolutely straight. Now in the next one, I have y equals 1/2 x plus 3. Now this one, instead of doing -1, 0, and 1, I'm noticing here that I have a half. So I'm thinking, what would make this easier to do if I'm going to multiply by half, which divides by half? And one thing that's easier to do is to use even numbers. So what I'm going to do on this one is I'm going to do -2, 0, 2, and 4. And you'll see why in a moment. It's a way of avoiding some fractions here. So for example, here in the first one, I get 1/2 times -2 plus 3. Well, 1/2 of minus 2 is -1. -1 plus 3 gives me 2. Notice how I ended up eliminating no fraction here in my number. Now 1/2 times 0 plus 3, that's 0, so this is 3. And then 1/2 times 2 plus 3. This time the halves cancel out and I get plus 1. Plus 3 is 4. And this time I have 1/2 times 4. 4 divided by 2 is 2, plus 3, and I get 5. Now it looks like it's going up by 1, right? You're saying, okay, it went up by 1. You may be asking, wait a second, isn't it supposed to go up by 1/2? Well, it does, because you notice on the x side, it's going up by 2. So 1 over 2, 1 over 2, 1 over 2. And let's look at what our coordinate pairs are going to be. It's going to be -2, 2, and then 0, 3, and then 2, 4, and 4, 5. So let's graph them. Start at the origin, -2, 2, 0, 1, 2, 3, 2, 4, and 4, 5. And then we draw our line. All right. One thing interesting to notice, if you're interested, is if I look at any points here, it goes up 1 and over 2. Up 1, which is right there again. That's our 1/2. That's our slope, as we're going to discover in the next chapter. 4 is similar. Again, notice I have a fraction here, 2/3. So the easiest thing to do is to let x be multiples of 3. So I'm going to let x be -3, 0, 3, and then 6. For the same reason, I eliminate fractions in my answers. So for the first one, -2/3 times -3, -1. Well, this cancels out, but a minus times a minus gives me a +2. So 2 minus 1 is 1. Then I have -2/3 times 0 minus 1. That's 0 minus 1, so we get -1. And then -2/3 times 3. The 3's eliminate. I get -2 minus 1, so we get -3. And then we have -2/3 times 6. 3 goes into 6 2 times, so I have -4 minus 1, which is -5. All right. Notice that it's going down by -2. But at the same time, this is going up +3. So together, it is -2 over 3, -2/3. So let's note what our pairs are going to be, ordered pairs. We have -3, 1. We have 0, -1. We have 3, -3. And we have 6, -5. So let's graph these points. First, from the origin again, x is first, -3, 2, 3 that way, and then +1 up. So there's our first point. Next is 0, so we don't go either place, but -1. And then we're going to go over 3, 1, 2, 3, and then down 3, 1, 2, 3. And then 6, 1, 2, 3, 4, 5, 6, down 5, 1, 2, 3, 4, 5. And if you did it right, they should all be in a straight line. So there's my straight line there. And again, as I pointed out last time, if I look at the change, as it goes over, it actually goes over 3, but then it goes down 2. -2 over 3, that's that there. In the next problem, I notice that we have an absolute value sign. So absolute value signs usually mean that the graph's going to look something like that with a V. So as I look at my graph, I want to find out kind of where is that point, where is the minimum at? And the way to find that is to look here at x plus 2 and ask, what value of x will cause that absolute value to be 0? Well, if x plus 2 equals 0, it means it's subtracting 2 from both sides. That is when x equals minus 2. So that's going to be this point here, the middle. So I'm going to put that right here. And that's going to be my low point here. And then I'm just going to put 2 on each side just to make it spread out a little bit. So we're going to subtract 2, add 2, and then add 4. And those will be the 4 values that I choose. So let's find out what y will be when we have these 4 values of x. So absolute value of minus 4 plus 2. Well, minus 4 plus 2 is going to be absolute value of minus 2, which is positive 2. The absolute value is always positive. It's how far is the number from 0, and distance is always positive. The next one, minus 2 plus 2, not surprising, that's the absolute value of 0, which is 0. That's what we expected when we set it up. And then the absolute value of 0 plus 2 is going to be the absolute value of 2, which is 2 again. And then finally, the absolute value of 2 plus 2 is the absolute value of 4, or 4. So let's graph it. Our notes here are going to be, our coordinate pairs are negative 4, 2, negative 2, 0, and then 0, 2, and then 2, 4. Okay. So the first one is negative 4, 2. So from the origin, 1, 2, 3, 4 to the left, and then up 2. There's our first one. Second one, negative 2, so from the origin, over 2 and up, and 0. And then we have 0, up 2, and then finally 2, up 4. And you see our V taking shape. So if I want to graph this, I'm going to have one line going up that way, and the other line going up that way. Notice how these are on the same line. I mean, if I wanted to, I could even go so far as to say, I know that the next one here is going to be here, and because they're going to be offsetting each other. You're going to have a symmetry. So just like these two are the same, these two be the same y all the way up as you go. Problem 6 has a quadratic, x squared. Got to be a little careful here because x squareds can get big in a hurry and go off the top of the graph. But I also notice usually if there's an x squared, if there's not another term like a 2x or a 3x, that is x minus x equals 0 is going to be my symmetry line. So that means I'm going to want to put in here, probably my 0 is going to be my line here. And then I'm going to go on the other side. I notice that 2 squared will give me 4. That'll only go up to 1. And 3 squared, so I can go as high as 3. So let's do this. Let's put a negative 1, a 1, and then let's do a 2 here. And so first of all, I have negative 1 squared minus 3, which is simply going to be 1 minus 3. Remember, a negative times a negative is positive, so this will be negative 2. Now we put in 0 squared minus 3, that's just 0. So that's going to be minus 3. And then for 1, we have 1 squared minus 3 equals, again, 1 minus 3, or negative 2. Notice these two are going to pair up and be the same y. And then 2, we're going to have 2 squared minus 3 is 4 minus 3, which is going to be 1. Interesting thing, if I wanted to notice here, if I went up here and put a minus 2, notice that I would get a minus 2 squared minus 3, and that would give me another 1 on that side, matching these two up, and that's the way the squares work. If I put all these points in, notice up here, if I even include that one, that's minus 2, 1. This is minus 1, minus 2, and this is going to be 0, minus 3. And this is going to be 1 minus 2, and then this is going to be 2, 1. Okay, so let's graph it. From here, negative 2, 1, and then we have negative 1 down 2, negative 2, and then we have 0 minus 3, And now we start coming back up, 1 minus 2 and 2, 1. Notice if I were to put in another number, like if I were to put in a 3, okay, that would be 3 squared minus 3, which would be 9 minus 3, which would be 6. So I could come over here and go 3, 1, 2, 3, 4, 5, 6. And because it's parallel, I know that I could come over here to minus 3 and put a parallel one in that. So you could fill it in that way too. In other words, I know that minus 3 is going to be minus 6 because minus 3 squared is also going to be 9 minus 3. Just if you're trying to get more points in there. So let's graph it. We obviously have a quadratic, and it's going to be a parabola, and so we're just going to gently flow through there and get our U shape like that. Once again, notice we have an absolute value in problem 7. So I'm going to ask, when is that 0? And when does x minus 2 equal 0? We'll add 2 to both sides, and you see it's when x equals 2. So I'm going to make 2 my middle because that's going to be where the point of symmetry is. So let's skip 2 on each side. 0 there, 4, and 6. Okay? Sometimes when I do these problems in a symmetry, I like to have 5 problems. I'd like to go back to minus 2, for example, and it would match up with 6. But nonetheless, we'll go here. So first off, 0. So I have the absolute value of 0 minus 2 plus 3. Well, that's going to be the absolute value of minus 2 plus 3. Absolute value of minus 2 is 2. 2 plus 3 is going to be 5. Next, I have the absolute value of 2 minus 2 plus 3, which is going to be 0 plus 3. So that's our low point there. And then we go back to 4, and we have the absolute value of 4 minus 2 plus 3. That's going to be the absolute value of 2 plus 3. So that's 2 plus 3 and 5. Again, notice these two it came down to 3, and now it's going back up. And when we put in 6, the absolute value of 6 minus 2 plus 3 is going to be the absolute value of 4 plus 3. That's a positive 4. It will give me 7. By the way, that would also mean up here, if I went up here and went minus 2, I would end up with 7 as well. And those two would match up. Okay, minus 2 would give me minus 4, absolute value positive 4. So I can notice some things here. I have the point minus 2, 7. I have the point 0, 5. I have the point 2, 3. I have 4, 5. And 6, 7. All right, so let's graph. First one, negative 2, 7. 1, 2, 3, 4, 5, 6, 7. And then 0, 5, 0, 1, 2, 3, 4, 5. And then 2, 3, over 2, up 3. Now we're going to start going back up. Over 4, up 5. Notice how those are on the same line. And then 6, 7. Over 6. And then up 7. And then we can graph our line. So one line's going this way, and one line's going this way. And that's the absolute value function. Again, notice how these two are on the same line and these two. That's because these are symmetrical around this line right here, the x equal 2 line. All right, number 8 gives us a cubic function, x cubed. This one gets big even faster than the x squared. You can imagine 2, 4, 8, it just gets bigger in a hurry, especially like 3, 9, now we're up to 27. So we're going to, and nice thing is because there's no other terms but this, it's going to be centered around x equals 0. So we're going to have our 0 term here. And I want to do something here. I'm going to do 0, 1, and 2. But going backwards, I'm going to do minus 1 and minus 2. Like I said, some of these symmetricals I prefer to have 5, and next year I'll probably, on this homework help, expand it so that it has 5 for you. But let's get started. First off, let's just start with the middle one here. 0 cubed plus 1 is 0 plus 1 is 1. okay? 1 cubed plus 1. 1 times 1 times 1, that's 1 plus 1, that's 2. Not too bad. And then we get 2 cubed plus 1, and that's going to be 8 plus 1, or 9. Now notice the one thing different from the squared when I start going to negative. Negative 1 to the cubed plus 1. A negative times a negative times a negative is a negative. So I end up with negative 1 plus 1, or 0. All right? Likewise, negative 2 cubed plus 1. Negative times negative, negative. This is going to be negative 8 plus 1, which is going to be negative 7. So we don't have the kind of symmetry, although it's kind of a flipped over symmetry when we actually do it. So let's take a look at what numbers we have to graph. And so here I have minus 2, minus 7. I have minus 1, 0. I have 0, 1. I have 1, 2. And I have 2, 9. So let's graph these. First, negative 2 over 2, and then down 7. 1, 2, 3, 4, 5, 6, 7. There's my first term. And then negative 1, 0 over negative 1, 0. And then 0, 1. And then we have 1, 2. And then we have 2, 9. Now you'll notice I kind of know what it looks like. You might be looking and going, I can't figure that out. But it kind of looks like if I took a parabola and split it in half and took this side and flipped it, it would look kind of like that. And that's what we have here. We have, if I put this in here, we've got it coming up from the bottom and then swinging through there and then coming up that way. And that's what a cubic function looks like. All right? I hope this helps you with your homework today. Have a good day in class tomorrow.